this is Laura, your Saxon math translator, and today we are starting Algebra 1, and that is the Saxon Algebra 1 book. The one I'm using is the 2009 book, and it's got a big picture of a camera on the cover. Please make sure that you have the right book and you are listening to the right lessons, otherwise you will be very confused. There's also an Algebra 1 book that's orange and blue, and those are different lessons, so you need to go back on the website and get the right book. Okay, Happy New Year for math. Let's get going. Lesson 1, classifying real numbers. Okay, what are real numbers? Now, some people may be snarky and say, oh, what about the imaginary numbers? Well, if they're not real, then they must be imaginary. And yes, there are imaginary numbers. We're just not talking about them today. We are talking about the real numbers. And there are two categories of real numbers. There's the rational numbers and the irrational numbers. Now, irrational in this case does not mean crazy. They're not crazy numbers, but they are different numbers, and we will get to those in a moment. First, we're going to go through the rational numbers, the ones that are not crazy. And we start with all the numbers, any numbers, 1, 2, 0, negatives, positives, all of them. And this, remember if you look at a number line and it kind of, you have this, 1, 2. Now, 1 and 2 are not the only numbers on that number line. There's a whole bunch of tiny numbers in between there. We just don't write them out all the time. So those are the rational numbers. They're the ones, the twos, the twos, and everything in between here. The 1/2s, the 0.3 repeating, the 0.125, everything in between there. They also include all of the negative numbers. So you've got them all when you look at these numbers. Okay, the next group is we take out those middle numbers and we only have the negatives and the positives. Nothing in between. Those are called the integers. Then if we take out the negatives and we keep 0 and on, those are the whole numbers. So they start at 0 and they go on forever. Next and finally are the natural numbers or the counting numbers. Well, you never start counting with something and start with, oh, here's this one, it's 0. So that does not include 0. It starts with 1. I have 1 or I have none. But when we count, we never pick up something and say 0. No, we pick up and say 1, 2, 3, 4, 5, and on for infinity. Those are called the natural numbers. They are also sometimes called the counting numbers. Now, here's the deal. These are the tricky questions that you're going to have to answer today. And they go like this. Is a natural number a counting number? Well, yes, it is. Is a rational number a whole number? Well, no, it's not, because whole numbers do not include the fractions and the partial numbers in between. There is no 2.5 in the whole numbers. There's just a 2 and a 3. Are integers rational numbers? Yes, they are. Are rational numbers integers? No, they aren't, because the rational numbers include negative fractions and integers aren't about fractions. So this can be a little bit tricky. Now, if we skip over here to the irrational numbers, those are like the cube root of 5. Anything with a square root, unless it is the square root of, say, 4, because the square root of 4 is actually 2. That's a rational number, integer, whole number, and counting number. But if you have something that has a pi tacked on to the end of it, that is also considered an irrational number, because pi goes on forever and it never repeats. So that is considered irrational. So try and write this down in your notes. You're going to have to know the differences between all of these types of numbers. If you need to stop the video, please do so. I'm moving on. All right. For each number, identify the subset of real numbers to which it belongs. Okay. Pause and give this a try on your own. Okay, I'm going to get going and tell you what they are. 1/2. Is it a counting number? No. Whole number? No. Integer? No. Rational number? Yes. It is a rational number. Now, we can also, and in your book, it says also real numbers. It's rational and real. Well, all of these are real numbers. We're only doing real numbers, so that's going to be an answer for everyone. All right, now look at 5. Is 5 a counting number? Yes, so it is a natural number. Does it fit in the whole numbers? You can look back if you need to. 5, yes, it's a whole number. And it is also an integer. And it is also a rational number. So 5 and numbers like 5, they got everything. They're in every category. So now 3 square root of 2. Well, what did I say? If there's a square root attached to it or a pi attached to it, we already know that it's going to be irrational. So I put real here. I could just automatically go and put real on all of them and not even think twice because they're all real numbers. All right, so this is how we categorize the numbers. You're going to have to do that in the lesson practice, so be prepared. All right, number 2, identify the set of numbers that best describes each situation and explain your choice. Well, we might want to talk about these a little bit because sometimes the way they're worded can be a little bit confusing. For example, it says the value of the bills in a person's wallet. Can you have a bill that has a value of 0? No, then it's not a whole number. Can you have the value of a bill that is negative? No, then it's not an integer. And there certainly isn't a bill that has a value of a decimal or a fraction. So that makes these all natural numbers. But if you look in your book, it says whole numbers best describes the situation. Well, they say the wallet may contain no bills or any number of bills. Well, if it has no bills, I guess you could say it's whole numbers. But if there is no bill, it has no value. So you can't even assess what the value is. The value isn't usually 0 if there isn't one. If you have a bill, it has a value. So I'm not going to argue with the book, though. What I will tell you is I will accept either answer, whole or natural. The balance of a checking account. Okay, this one can be a little bit tricky too. Can you have, money is, you can have $2.57. You can have $100.50. So we have decimals. That means it works for which group? If you have to look back. That means it's the middle ones, the rationals. So this works for rational numbers. And what else? What's next? After rational, do we have integers? That's positives and negatives. Does it fit with integers? Can you have a negative account? Well, technically you can't have negative money, but you can have a negative account, which means you owe them money. So that's integers. And then, of course, also, I'm going to have to squeak it in here, the whole numbers and the counting numbers. They all fit for this particular situation. Now, the circumference of a circular table. It's a circle. The circumference, that means it includes, it doesn't even matter if the diameter is a rational number. It includes pi. That means it's going to be irrational. Anything that includes pi is going to be irrational. Okay, let's move on. Oh, more notes, definitions, tables, etc. Okay, you need to write these down, and it's best not to listen and write at the same time. So either listen now and pause after, or pause now and listen after. Okay, so either you are listening now or you've got them written down. Let's talk about these things. You probably have seen them before in, like, I don't know, 6th grade, 5th grade, maybe even 7th grade. A set. What is a set? It is a collection of objects. For example, this is a set of letters A, B, C, D, F. And you can see that if we have 5 elements, the element is the object in the set. For example, the highlighted element is B. There are 5 elements. One of the elements is blue. The braces are these cool little things that we write. I gotta tell you, I had a challenge when I was growing up taking math, writing these. I'm a little bit better now. There's mine. If you can't write them, I don't care if you just do a little squiggly mark. That will be fine. I will understand. Your parents will understand. Everybody will get the point. They don't have to be perfect. And if somebody tells you they do, let them listen to the video, because I'm telling them they don't have to be perfect. Okay, the empty set. Anything that you get when it says, oh, which ones are these? And you say, well, there aren't any in there. That's the empty set. That set is empty. And you can either do it with these 2 empty braces, these 2 empty braces, or the empty set symbol, which is this 0 with a line through it. Okay, a finite set. Finite means limited. That means this, for example, is the set of 1, 2, 3, 4. Not 1, 2, 3, 4, 5. Not 0, 1, 2, 3, 4. Not 1, 2, 3, 4 in somebody's shoe. No, it's just 1, 2, 3, and 4. If it's an infinite set, meaning that it goes on forever, then it can start at 1, 2, 3, 4, and these little dots here mean that it does go on forever, so it would be 5, 6, 7, 8, 9, 10, 11, on to infinity. And these little 3 dots, you may not have known, actually are called ellipses. It's not an ellipse, which is a shape. These are ellipses, and that indicates a continuous list, and it's just 3 dots. You probably used them before and didn't know they had a cool name like ellipsis. Now you can impress your friends and family. More with sets. We have the intersection and the union of a set. The intersection is the sets that are common in both. So if we look at A and B, we can see that C is in both of these sets. And the way we write that is A intersects B, or A intersection B, or where A intersects B is at C. And we put C in the little brackets. That's the only thing they have in common. Now the union is just everything everywhere. It's like everything in both suitcases, 2 boxes. We just dump it all in a pot and make a big soup out of it. And the union is just a big U, that symbol. And so you say the union of A and B, here's our A and B, is A, C, E, B, and D. Or you could put them in order, A, B, C, D, and E. And you don't have to write the C twice. You can just put it one time. Okay, a closed set. A set is closed if the outcome of any 2 members is also a member. For example, the sum of 2 natural numbers, those are the counting numbers, remember. The sum adding of 2 natural numbers is a natural number, so it is closed under addition. No matter which 2 numbers you pick, if you add them together, you're going to get a natural number. So they call that closed. Now, sometimes they are not closed. And if they are not closed, you provide a counterexample. And that is just an example that proves a statement false. We will see that in just a moment. Okay, if you have to pause now to get all those notes, then please do so. I am ready to move on. All right, find a intersection B and a union B. Well, we can do that easy enough, can't we? The A intersection B, well, that is not very tidy. A intersection B is, what do they have in common? 2, 4, 6, 8, 10, 12, 3, 6. Here's a 6, there's 6. Ooh, and a 12 and a 12. So here they have 6 and 12. Now, the A union B, the union of A and B is 2, 4, 6, 8, 10, 12, and 3, 6, 9, 12. Now, I don't have to write them twice. So I'm going to do 2, 3, 4, there's no 5, there's a 6, 8, 9, 10, and 12. There we are. Now, let's see this one. A intersection of B is 11, 13, 15, 17, 12, 14. Uh-oh. They have none in common. So either I have to write that or I have to write that. Now the A union B. I hope you're getting these on your own and not just waiting for me. That's all of them. 11, 12, 13, 14, 15, 16, 17. But I'll tell you what, you do not have to write them in order. 11, 13, 15, 17, 12, 14, 16, and 18. There we go. See? Hey, look. That one's kind of messy. Still okay. All right, let's move on. Again, try these on your own and see how you do, and then come back and start the video so that you can check your answers. It's really good if you can get them on your own. Okay. Example 4. Determine whether each statement is true or false. Give a counterexample for false statements. Oh, there's going to be some thinking involved. The set of whole numbers is closed under addition. Okay, so we're going to be adding, and it's whole numbers. That's the 0, 1, 2, 3, on and on and on. So I could pick any number. I could pick 10 and 15 and add them together, and it gets me a whole number. Is there anything that gets me something that isn't a whole number? Can you get a negative? Not if you're adding. Can you get a fraction? No, not if you're adding. So this one is true. The set of whole numbers is closed under subtraction. Oh, still these numbers up here, but let's just say I have 3 minus 1. Even if I had like 13 minus 11, then that's okay. That's just going to get us a 2. But what if I had 11 minus 13? That's going to give me a negative 2, and that is not a whole number. So here is my example. So this is false, and my counterexample is 11 minus 13 equals negative 2. Okay, you will notice that I always circle or box my answers because I'm very tidy. You should be tidy too, as tidy as possible. People want to find your answers and look at them. They don't want to have to search through your work. Okay. What is this? For each number, identify the subsets of real numbers to which it belongs. Hey, this is the lesson practice. We'll do this first one, and then you guys are on your own. For each number, identify the subsets of real numbers. Well, this one is negative, so I already know that it's integers. And if it's negative, we know that it's the real. They're all real. We know that it's rational. And we know that they are integers. Okay. Here we have a fraction, so we know it's not counting numbers, it's not whole numbers, and it's not integers. It's just the real numbers, since they all are for us here, and rational. And, ta-da, anything with a pi is irrational. Okay, the rest of what you have today is almost exactly what we did in our examples. So you should be fine with the lesson practice. And then there's a lot of review going on for the practice problems. Your homework, 30 problems. I don't know if your parents or whoever's in charge of you is going to make you do all of them, but you got to get back in the zone at some point. So you might as well start by doing the math tonight. Okay, friends, we will see you again tomorrow for lesson 2. Shalom.